correct. Oh, those are the examples of parabola, and that is correct. No, so I did mention this one already. I did give a tip for your peta, okay? Because what we need in your peta is a function. And in order for us to find the function, I did mention that one that you should look if the equation, if the uh, function that you have is a function. How would you know if it's function or not? So later on, we are going to discuss that one in our enhancement class. Okay? All right. So with that said, let's go already in our thing. So we are going to watch a recorded video of mine so that once you are going to have a recall in your own side, for example, later on or tomorrow or in your offline week, you could just continue, no? So that you will not start right away in the beginning. Okay? Sige po. All right. So let's start with this.
All right, so good, or what we could say with regards to
Grade 10, kindly ready your journals. Maybe you are not yet doing your journals. You could have take down notes. Okay.
the ellipse, isn't it? Then this will help and save today and always.
Let's
Burdens
start
you
here.
are pray for us. In the name of the Father, the Son, and
Is
the
it
Holy
loud and
Spirit.
clear? The video?
All right. So,
Sige po.
in this video, as I mentioned a while ago, we are going to discuss a new topic in connect section. And maybe some of you already watched my previous video with regards to the ellipse, isn't it? Then, in this video, we are going to discuss about parabola. Right? So, in this video, we're going to deal with parabola. But, question is, what is parabola? Okay, so by definition, a parabola is a set of points in a plane that are equidistant from a fixed line. Fixed line called the directrix. Okay, so directrix is a fixed line, no? And the fixed point called as the focus. So a parabola is somewhat a half, no? Half, or what we could say that it is the figure in some reason there are there are people who are telling that it's a half of ellipse. But parabola, no, performs or shows a graph, no, showing a U form, no, with its set of points that are being uh, created from the two fixed line and fixed point. Okay? So with the distance that you are getting from your fixed line and your fixed point, you're getting this locus of the parabola. Okay? And just to add up, in this parabola, we are not just getting the points or the set of points coming from your parabola, but also in your parabola, you have parts. So what are the parts of parabola? Of course, you have the focus, directrix, no? And as well as the axis of symmetry. If you say axis of symmetry, that is the axis that passes, or the line that passes through the focus. Okay? Passes through the focus and creates a perpendicular line towards your directrix. Okay? So, what else? Aside from axis of symmetry, this is the axis of symmetry, ha? Axis of symmetry. Alright? This is double M. Alright, so aside from the axis of symmetry, we also have what we call as latus rectum. So latus rectum is the length of the width of your graph. No, so you cannot really tell.
What is our latus rectum? Latus rectum is the width of the graph. If you say width, yung lapad. So how are we going to know if our parabola is opening just like this width, or opening wider? Okay? So it depends on the latus rectum. Continue. Continue.
How wide your graph would be or how narrow your graph would be. Okay, so in this case, we're going to have our latus rectum. So in this case, I'm going to show you the parts of a parabola. Now, we have the axis of symmetry, this one, the latus rectum, the focus, the rectrix, and lastly, the vertex. In some cases, in the conic section, there's always a center, isn't it? But in this case, you only have the vertex, all right? So vertex will vary. So sometimes it might be in the origin. So sometimes it's in the H and K's, no? No? But before that, let us have some examples in real life, no, of parabolas, no. So here are some of the pictures of the real life examples of parabola. So we have this bridge. It is familiar. Is it familiar? Yes. No. So it is a famous bridge. I guess this is the San Francisco Bridge, and as well as some of the bridge that you could saw that performs or create a parabolic structure. All right. So as well as for this. Okay, so with bridges, parabolic structures, no, are commonly seen to our society or our environment. But no, but of course, not only just we cannot just simply see this parabolic formations, not just in our bridges, but also in some kind of theaters, no, the Sydney, okay, and as well as for our entertainments or rides like the roller coaster, okay. But of course, we cannot just simply find parabolic figures or structures outside of our home. Of course, you could also see inside your household. But, okay, and of course, lastly, sometimes you could see as well parabolic figures in what do you call this one? We could also see in some kind of a telecommunication site or satellite. Okay. All right. So, but before that, yes, it performs this example performs and shows a figure of parabolic. Now, but the question is, how are we going to graph or create a graph, no, of a parabola? Okay, so of course, you should know what are the general form of parabola. So we have two. So those are the vertical general form and for the horizontal general form. So in vertical, we have x squared plus bx plus ey plus f is equal to 0, wherein your e is not equal to 0. Ha? And for horizontal, you have y squared plus bx plus ey plus f is equal to 0, wherein your d, in this case, is not equals to 0. Okay, so I want you
All right.
to
So
remember.
for this one, if you say general formula or general form, if you will remember the formula in circle and ellipse. In circle, the radius is outside, correct? Then once the radius is inside the this one expression, no, then you have equals to 0. That is in general form. Okay, so if you will notice in vertical and horizontal, it is equal to 0. So what we do in that radius is we transpose that one to the other side, to the side of 0. So we could have the standard form. Okay, that is for the circle. Now, for the ellipse, isn't it that the formula of ellipse is that there is a fraction for x and y, and the denominators are the vertices and co-vertices, then it is equals to 1, correct? So 1 could be represented, for example, could be represented as 144 or any number. So how are we going to get the proper standard form for ellipse? We're going to eliminate the value for 1. Isn't it that it should be 1, not for 144? What are we going to do? Divide it to itself. Okay? If we divide it to itself, we're going to divide it to the other side as well. Both fraction, the same. Okay? Ganon. Okay? So, I will be showing you some slides. Ha? For example, this one. Because that is where the... That is where... That's right. Alright. So that is where the standard form and general form are taking place. No, so for example, just like this. If you have, let's just say, x minus 3, then you have x minus 3 squared plus y minus 2 squared, correct? Then is equal to 1. Let's just say it should be variable like 4 and 9, then 1. That's the standard form. But if it will be general form already, let's just say this is x minus 3 squared, then this is 9 plus 4 y minus 2 okay, squared is equal to 36. If that's the case, that is an ellipse. How are we, that is in general form, ha? How are we going to find? Or it could be in a manner of just like this, 9x minus 3 squared plus 4 y minus 2. This is y, ha? Y minus 2 squared minus 36. This could be ellipse. So it varies if it's in standard form or general form. How are we going to find if it's ellipse? With the degree. Take note, the degree. Okay? And also, if it's positive. Because we are going to encounter in parabola, it is in different manner. It only has 1 degree. Ibig sabihin, yung x or y mo, siya lang yung merong square root. Okay? Or square. Okay? Alright, so in this case, if you will notice, how are we going to convert this one into standard form? You're going to transpose this one, so it will become just like this, correct? So once after you have this standard formal, this equation already, it's 9 multiplied by the quantity of x minus 3 squared, okay, until this one. You're going to dismiss this 36. You don't want 36 at the side in order for it to become ellipse. You need 1. How are we going to make it 1? We divide it by itself by 36, and as well as this term as 36. This one, not this one. I will be writing it down as this term. I write this one as 36 and as well as 36. In this case, if you know, in adding and subtracting fractions, correct? You could input this term as just like this, 9x minus 3 squared over 36 plus 4y minus 2 squared over 36. Could be that one. Okay? Then equals to 1 because 36 over 30 is equal to 1. Now, you now have this form. But remember, in the standard form of your ellipse, you don't have any coefficient beside this two x or two intercepts. Correct? So what are you going to do to these numbers? You're going to divide this one with this one, or get the lowest term of that fraction. How are you going to get the lowest term? By its L or by its GCF. Okay, GCF of 9 and 36, it's 4. So 9 and 6, you could have the lowest term of 4. Correct? So 36 divided by 4, 4. Divisible, 9 is divisible by 9, so it will become 1. So 36 divided by 9 or divisible by 9, it will become 4. Same goes by the other side. So if you have 4, 4 is divisible by 4, it's 1. So 36 is divisible by 4, so it is 9. So in this case, you can now divide or you can now proceed.
Did prepare some table for what are the things that you need to uh, remember how to plot the coordinates of each parts, no? Each parts of the parabola. In ellipse, we have seen and we knew about these parts of conic sections, most likely in ellipse, no? The vertex, the foci, the center, no? The co-vertices, all right? So we were able to locate them and put the location by its coordinates. So in this case, in parabola, we also have coordinates. So how are we going to find the coordinates? So here's the table po. Okay? So we also have this standard equation. So coming from your general form, you could have a standard equation of each figure po. So there are two, isn't it? So horizontal and vertical po. Okay, so when you have the standard equation of y squared is equal to 4c x, no? No? Your graph is opening to the right. So I want you to remember these things first. Okay, so when you have the negative ones, of course, it's opening to the left. Okay? And as you will notice, if you have y squared, no, your axis of symmetry is at x-axis of. What is the tip? In order for you to identify and remember the axis of symmetry of each equation. So in this case, the axis of symmetry, you could easily found the axis of symmetry based on its variable within the equation, no? Without square, okay? All right. So in this case, we have x. That's why your axis of symmetry is at x axis. Now same goes by for the other one. Even though it's negative, it's still in x axis. But even though it's in x axis or even though it's in x axis, you will notice as it becomes negative, it is opening to the left. Why is it opening to the left? Because all the things that you could see on the left side of your x-axis are all negative. Same goes by for your positive one. No? When you have the positive one, all axis, the graph of your the opening of your graph is facing to the right because all of the coordinates that you could find in your x-axis to the right is all positive. No, so same goes by with this x squared. But no, so for from your standard equation, if you have x squared, all right. If you will notice, the axis of symmetry of it is y-axis because the variable next to it is 1, as well as for the negative ones. But take note, if your axis of symmetry is y-axis, of course, in Cartesian plane, this is the y-axis. So therefore, your parabola could be facing upwards or downwards. So how are you going to know whether if it's positive or negative? So if it's positive, it is opening upward. Okay? When it's negative, it is facing downward. Only that one. Alright, so what else? I'm teaching you already how to identify the fastest way in the parts of your parabola. Okay? Alright. So, um, in the general form, let's let's have y squared is equal to 4c x. Sometimes the 4c in some other lessons or some other modules, it is stated as 4p. But in our case, it is 4c. Alright, so 4c. Okay, so let's just have this parabola graph, graphic parabola. Okay, alright. So this is the standard equation, first of all. Okay, and if you have an example, um, your x-axis in here, your axis of symmetry in here is x-axis. So therefore, your graph is facing right or left po. Okay, it's facing right or left. Okay, so when your equation is uh, facing to the right, so it means it's positive. Your equation is positive. When it's facing to the left, of course, your equation is negative. So let's have this example. Okay. All right. So this is the first example. So we have to find. No, we are going to sketch and discuss these three following. So we are going to sketch this equation as well as this equation and sketch this equation. So this given. Also, we are going to sketch three graphs po. Okay, so let's try it for the first given. Alright, so this is the first given. So in this after given, we will get this. What are the equation that we could have in this equation? That number number equation we have it y is equal to negative 4 x is the next. Alright. So, in this case, what we're going to do here is find versus the vertex. Okay. What is our vertex? What is our focus? And what our direct? Okay. As well as the values. Okay. Alright. So first of all, I want to tell you that when it is in for C, excellent. But when it was not, it will belong positive for C. But even though it's not positive, I want to use, I want to tell you with regards to this number, no, because in equation, you have C and negative, a number L, you could have less this forward, no? For C is equal to the value of that number. So therefore, it's a negative. You just quit it by negative. Okay? Your force is equal to negative. Okay? So it only means that the value of this is your force. No? Okay? So, force is equal to what happens? Okay? That is it. Alright. So, let's try to have this. So, we're going to locate the value of C1. This is the question. What is this? Alright, so from the graph, for example, this is your first. This is example, for example. And you have to focus in this. For example, you have a graph of this parabola. Then, if you have a vertex, you have the focus. The distance between the vertex and the focus is what all this distance of C. Okay, and you're find the focus is that the C is our focus in it is distance of your focus is the distance from the vertex to your focus. It is the value of C. It is the focus. Then the other way around, in order for you for focus is equal to C. In order for you to find the direct, you need to subtract subtract the value or this will distance because whenever the distance that you have from your vertex up until your foot, it is the distance um, from your vertex to the vertex. So they are equal distance on the foot and then the vertex. Alright, so if you have the value of C, we're going to find the value of C. So, this case, so the first thing we do is find the value of C. Okay? So, our first find the value of C, of course, is equal to negative 12. Right? So, the only thing that we give is the value of C. So, we're going to divide both sides by 4. So, I'm going to 4 and have the value of C equal to negative 12 over. And in that case, no? In that case, you could already know. You could already know. You could already know that, that your C is equal to negative 3. Alright? So, you have the both already. But I don't want to know what the structure is. Or what the vertex. So here's the thing. As I mentioned, the most important formula coming from circle, coming from the circle is R squared is equal to x squared plus 1. This is a formula when the center of your circle is at the origin. No? And once you have the values of the center, so you have the h equal already generated. We're going to add this as x minus h squared and y minus k squared. And then that's the form. But in this case, did you ever see an h or h and a none? Therefore, the center or vertex of it will be at the origin. Okay, so the vertex of it will be at the origin. Now, when you have the vertex already, so you find the vertex of the origin. So when you have the vertex and you have this already, can you locate already what the origin of your purpose? Of course, the origin of your purpose is that negative 0. Okay, so therefore this is negative and 0. So why is it x-intercept? Because your x-axis or axis of x equals the number or your 4c, the variable beside 4c is expo. Is it?
All right, so grade 10, what I'm telling you there is that as you will notice, in position circle, we always be at the center, right? And we do not enter for circle and because they have a figure or closed figure or open. So in this case, we only have parabola and it is open. Therefore, we don't have any center. Now, what we are affecting is only the vertex, or you can literally edit with of major axis. So the major axis right, is our axis of symmetry. Okay, so if this is your vertex, okay, and this is your major axis, this one. So if you have only this graph, you have the this one axis of symmetry, and this is your vertex. Okay, so you will depend on the vertex and axis of symmetry. How are you going to identify if it's x-intercept or y-intercept? Based on the equation. You will notice that the standard form of the parabola is y squared is equal to 4c. 4c then x. Or sometimes it will be x squared is equal to 4c then variable. Okay, so what happens then is that whatever the variable, whatever is the variable that doesn't have
add at the other side, no? So you're going to input 3 at your right side, no? So what are you going to do? You're going to put your positive 3 at your x-axis as well. So therefore, it will be why this is this one or this one. You know, no, for suppose you lack something, what is the lacking? Lacking is lactose corrected. So how are you going to find the value of lactose? In order for us to find the value of lactose, um, if you have an example, so an example, so whatever the distance between your focus up until to the end or the tail, so your or the endpoints of your focus up until to the end, value of that one will be 2cc. Okay. So if they if you have 2cc, you can have as well 2c and the others. So therefore they are equidistant as well. No? Because it is just the width that we are talking about. So in total, you could have 4cc. Alright? So get alright. So if you have 2cc, what is the value of 2cc? You have 2cc, you're going to add just the distance na the multiplication or operation. So from one point, you have already cc, and then you have the cc. So you're going to multiply positive, negative, cc. Where are you going to input? Where you going to input this what this one DZ for your data. You're going to input the value of your data at your y. Alright. So if you have the positive vector, it is 0, 0. But what is your focus? We're going to find here from your focus, you have negative 3, negative 3, plus or minus what? Plus or minus, I'm sorry, this is the one. Negative 3, and your y-axis will be plus or minus 2. Okay? That's how. So what is 2c? What is your c? The value of your c is that your c is just negative 3. So you're going to add c to your focus. So you're going to add it twice. What is twice? You see twice. No, you're going to have 3 and 100. So therefore, this is your last next. Okay, 2 minus 3, the answer is positive 6. But when 2 multiplied by negative 3, what's the answer? Of course, if you have positive 2 times multiplied by negative 3, the answer is negative 3. A negative 6, sorry. But when you have negative 2 multiplied by negative 3, the answer is positive 6. No? So therefore, you will add 6 and you are going to minus 6 as well. Okay, this is for the y-intercept po. Okay, so I'll just erase this one.
All right, so for lacus rectum, we're going to identify what is the coordinate of lacus rectum. We are going to base on the focus. Okay, if the focus based on the vertex, the latus rectum will based on our focus. Okay, so the focus is -3 and 0. And what we get is that from the focus up until to the endpoint that we have in the graph, no, the intersection between the axis for latus rectum and the graph itself, the intersection point of that one is going to be at the distance from the focus up until to that endpoint. The distance of that one is that is the value of your 2C. Okay? And we are going to add and subtract that one to our focus in order for us to get the distance or the axis that we are creating from our graph in order for us to know what is the width of it. Okay? There you go.
And to clear this. Ah, so you will have -3 and positive -6. All right, so these are the lattice rectum. So in that case, we could now graph your parabola. All right, so that's how we graph your parabola. Where is your axis of symmetry? This is the axis of symmetry. It's x1. Now you already know what is your directrix, your focus, vertex, and latus rectum. Okay, latus rectum. All right, clear? All right, so let's have the other example. So for your x squared is equal to 8. Sin goes by, it is x squared is equal to 4cx. So what is your 4c? Let's find for the value of c first. No?
That is why, that is
So
why.
4c is equal to 8. Your 4c is your 8. Okay? So we are going to find the value of c. We're going to divide both sides by 4. So therefore, c is equal to 8 divided by 4. The answer is 2. So therefore, our C, the value of C is 2. Okay ha? Alright. So the value of C is 2. C is equal to 2. Alright. So how about the vertex? Did you see any values of H and K? Were you able to see anything? No, of course. Therefore, our vertex is at the origin. Okay? Alright. So, in this case, Uh, how about how about the focus? How are we going to find the focus? It is dependable whether what is the axis of symmetry of this parabola, isn't it? What is the axis of symmetry? You input axis of symmetry. Let's just input AOS. No, AOS is the axis of symmetry. Symmetry. Alright, so axis of symmetry is y because you have y variable in your x squared form. Alright, so if it's y is the axis of symmetry, so therefore the focus will be inputted at the y-intercept po. Okay, so your f value or f coordinate will be 0 and 2. Okay, so it is positive 2, isn't it? So it's positive 2. So therefore, your directrix, no, will become, let's just input first. This is your vertex, and your focus will be at 0 and 2. This is your focus. So once you have the positive or you add, then therefore your directrix will be 0 and -2. Okay, so vice versa po. No, positive to negative. So therefore, this is your directrix. So this is the directrix. They are equidistant to each other. If you will notice, the distance or the magnitude of the focus and directrix are just equal. No, because they are equidistant. Okay, so how are we going to find, how are we going to know how wide it is? By the latus rectum. Okay, latus rectum. How are we going to find the latus rectum? Hmm. The value of it is 4c. Okay, so how are we going to find the 4c? From your distance of c, okay, that's the value of c, ha? C. This is your c. You have 2c in this part, 2c, isn't it? And 2c for the other side. So what is the value when you multiplied 2? It is 4. So therefore, just wait ha. So therefore, you have 2c is equal to 4. So therefore, you are going to have the points at your side 1, 2, 3, 4. So this is the point in your side, and you are going to have negative as well, ha? Because when you add, you subtract as well. Alright, so 1, 2, 3. This is your latus rectum. So you have now 4c in total. Now, because you have 2c in both sides. So in this case, you have now the graph of the parabola. So it's much easier, no, than the other things around. Okay. So how about the last one?
All right, so that is how we graph in parabola. So let's try naman if we have the values of h and k when the vertex is not in the origin. So it means your vertex has the values of h and k, ha? Sige po, because the last one is just similar. Try this one. But you could watch that one, so it could help you in identifying the things with regards to parabola. Okay?
So let's try, no? Let's try to deal with a parabola wherein they are not, wherein the vertex is not in the origin. So they have the values of h and k. Okay, so let's try po. Okay, so
So I'll be explaining in a fast manner, no? So if you will notice, they are just the same. It's just that we just added h and k. If you will remember the increments, no, in the formula from circle, we we have the values of center of the circle if you have x minus h squared, correct? So in this case, that is just the same. Just that there is a value of center. In the opening thing, wherever the graph is opening left side, upwards, downwards, or right side, it is just still the same. It's just that if you have the center, you just add. Or if you will notice, you just had, or from your focus, you based on your vertex. And which is your vertex? The H and K. Okay? Because in parabola, we don't have center. We only have the vertex. So your vertex here is your H and K. So what happens here is that, as I mentioned a while ago, your focus, you're going to depend on the vertex. Okay? So what happens here, from H and K, you have H and K. And you will notice that the value of C was added to the K. Why? Because we have the variables of Y in this tricks. Okay? That's how we get the axis of symmetry, ha? Same goes by to our lower part. We have y squared, oh. We have y squared, and the variable that doesn't have any squared is our x. So it means our axis of symmetry is x. So we are going to add the value of c at x-intercept. Oh. The c was added at x-intercept to the value of h. Okay? All right. So with that said, after that one, we're going to base from your latus rectum That is just the same. We're going to depend from your lato selector, we're going to depend on the focus itself. Whatever the value of your focus, if you got the coordinates already, just based on that one. Okay? All right. So let's deal with the example already. All right.
just
So
that
that
there
there
are
are
values
values
for them
for
to
them to
add
add
their
their
values.
values.
No? So
So
let's
let's
try to
try to
have
have
the
the
example
example.
for the first part. So if you will notice this, just the same, it's just that there are values for the h in case po. Now, so let's try to find the vertex first. What is your vertex? Your vertex in here is h and k. So what is your h? Your h is this one. This is your h. No, this is your h. What is your k? This is, I'm sorry, rather. This is your k. Always remember that the partner of x is your h. So this is h and this is k. Alright? So may I ask you, are the values of h and k are both positive? No. Why? What is the value of k? Let's try to find what's the value of k. The value of k is it negative 3?
I
It's
just skip this
positive
one because I know
3.
you know it
Positive
already.
3.
The values of
Okay,
H
so
in
how
K.
about this?
Positive
Negative 2.
two
In
and
k,
K
which
which
is
is
positive
positive.
3. Alright, so
Alright, so
we
we
have the
have the
vertex
vertex.
already. So let's try to plot it already. Negative 2. This is the negative 2. Negative 3. 1, 2, 3. So your vertex is located in here. No? Let's try to erase this one already. That is your vertex already, huh? This is your negative 2 and this is your negative 3. That's how we plot. Positive 3, I'm sorry. So our vertex is in here because it's positive. You will notice it's negative, then positive. So our vertex is at the other side. No, I'm sorry. Okay. So you have negative 2 and positive 3. Okay? So therefore, this is our vertex. Now, we're going to find what's next. Oh, what's next? We're going to find the focus. No? The focus. And in order for us to find what is focus, we're going to ask ourselves, no, whether what is the axis of symmetry? What is your axis of symmetry? Is it in x-intercept or y-intercept? Mm. Just take note from the equation that you have right now. This is just the same from the equations that you have at the first place.
It's
Just
I
just
will
that
that
skip this
it
one.
was just
I
added.
did mention this one as well. Na our axis of symmetry there is x because x doesn't have any square compared to y. Y does have square. So we're going to skip this one, ha. So it's x intercept. Okay, so if this is our vertex already, let's find the value of c.
C, and
See,
it
and
will
it will
be
be
located
located
at
at
the x-intercept. And your placement for focus is at 3. Alright. So how are we
Please wait. So the time is about to end. I would like to call this meeting as to the end already, and I want you to continue this video. All right. So with that said, you may take your break, and thank you for joining. Bye.